Make Radio, and it's a new book we've published. So we've had a pretty good response to this. I'm going to let people take a few minutes for people to come in, and we'll go from there. There's really been over 100 years of radio experimenters, and I think this book continues in that tradition. And so I expect in our audience we have people who are really experienced and know radios a lot, and others who maybe have not. So I'd like to, if you're coming on right now, maybe if you in the chat just say hello, say where you're from, and if you're a beginner or an advanced radio hobbyist or experimenter, whatever term you want to call, that would be happy. We'd happy to see that. And I want to acknowledge one of the first to put in the chat. Charles Platt is in the room with us. Charles actually worked on this book, helping Fredrik, and it follows the methodology that Charles set out in his Make Electronics book, Learn by Discovery. Instead of explaining a lot of things, we try to show you here what's going on. Quite a few beginners. Some who have their ham license. Okay, I'm gonna see if I can share a screen here and show you a few things if that works out. No, not that. Back to that. Stop share. I don't know. I tried to put this together and see if it will work. While we're getting you coming in here. There we go. Share. There we are. Slideshow. I like the slideshow here. View slideshow. There we go. All right. Hopefully you can see this. This is the cover of Make Radio by Fredrik Jansson, who is our guest today. And as I said, we'll be talking about his book, but we'll leave a lot of time for questions. So this is a subject that I hope many of you do have questions for. This is Fredrik, who will join us in a minute. And just to give you some flavor of the book, this is really the first chapter, and we'll go through a couple of the experiments in the book, and go from there. So I'm going to drop this so you see it. I will mention later that we have a kit associated with Make Radio that you can buy. So you can certainly source all your components like on the screen here, but you can also buy a kit from us. So good to see folks checking in here. JD in Houston, Lawrence in the UK, and he got a license recently. Fredrik and Phil, UK hobbyists. I'm actually kind of glad to see some folks from UK and Europe in here. We're doing this a little bit earlier than we normally do on the West Coast. Okay, Jamie, I'm going to stop sharing, and if you would bring Fredrik on. And if you are just joining us, if you put in the chat, your name and location, and kind of whether you're a beginner or experienced. Raymond Brick said he built his first crystal radio early in the 80s. Fredrik, welcome. Glad to have you here.
Thank you.
Where are you right now?
I'm in Turku, in Finland.
In Finland, yeah. And that's where you live. You go between the Netherlands, don't you?
Yes, I live mostly in the Netherlands and I work there, but I am from Finland.
Okay. Well, I'm happy to talk to you about radio. We have really a good audience joining us today, over 121 so far.
Nice.
And that's really maybe our best turnout ever. So let me just ask, it sounded to me like radio was was a set of experiences that led to you getting into electronics as a kid.
Yes, it came, I think, together with electronics somehow, like the desire to know how stuff works. And if you get a broken radio, you open it, and then you see some mysterious components in it, and you want to know more. And
Yeah,
I think this is the path.
yeah. Um, what kind of, do you remember the first radio you built?
The first radio I built only a few before the book. Oh yes, a kit, amateur radio kit. I also built.
Right.
Was nice. I remember the first ones I took apart with electron tubes, and of course I did
Hmm.
not understand how it works, but it was like the reason to learn more about it.
Uh-huh. Good. Well, why did you decide to write a book about radio?
So this came slowly, and it came very much thanks to Charles Platt, who has written many of the Make Electronics books. And we collaborated for a long time. I saw today, I know Charles since 12 years. And I've been participating somehow in his books, a few of them I fact-checked. And I was also co-author of some of the Encyclopedia of Electronic Components.
Hmm.
So I think this was the start. And then sometime during COVID, we just discussed what could be a good book topic. And then one of the suggestions was a book about radio, and that now turned into this book.
Okay, good. Um, so in some ways, it's not when I look at it, it's not really a beginner or a raw beginner book on radio. Would you agree with that?
It's probably true, but on the other hand, uh, it can well be your first radio book. Maybe
Hmm.
it should not be your first electronics book,
Hmm.
because if you know something about breadboards and you have seen the components before, it will definitely help. But
Hmm.
with a bit of this experience, I think you can start on this book.
Hmm.
That was the goal anyway. I
Right.
hope we made it, but who knows?
And so for the most part, you're kind of each of the main chapters are dedicated to explaining how to build a particular circuit, right?
Yes, yes.
Yeah.
So it's really the idea that this book should take you through the material through experiments. So the experiment always comes first, and then the explanations, how it works and why did we do it this way. But it starts with building something because it's such a good way to learn. And if you build it and you see it working, it's also a reason for you to learn. And otherwise, the theory on its own, while it might be interesting, it's a bit dry and it's not maybe so personal.
Right. And radios, in many ways, we talk about it, or I see people talking about it as sort of mysterious, magical, um,
Yes,
invisible. You have it's a hidden universe. So it's to some degree a little bit harder, as a tinkering um, topic, to really get your hands on it, other than
that's
building circuits.
that's really true, and it's been a frustration for me for a long time because I learned electronics and blink a LED and before LEDs the incandescent lamps and stuff, but radio was always uh, slightly out of reach. Uh, And of course, there are the crystal radios, but you quite soon run into issues with component availability. So, so you might find a book about building radios, but quite soon they will ask for some transistors that you don't have, and you also don't know where to buy. Or there will be these tuning capacitors or something that you can't really get, not even in the component shops necessarily.
Yeah.
So so that's one thing, and the other thing is because you can't see the radio waves. So when your circuits don't work, it's quite hard to know why. And with something which is more immediate, like LEDs or something, it's easier to, build it step by step, usually.
Yeah.
So maybe this is something I wanted to address with this book to really give radio experiments that you can get the components for today, and you can slowly build up towards more complicated circuits, but really start simple.
Right. And I think it's one of the comments you have in the book is that, well, maybe when you were young, it was hard to get these components, and
Yes,
the
yes.
world's made them more accessible for us today.
Yes, that's true. So the internet and the internet component shops definitely help, and then just choosing the right components. So you don't need to choose some very special radio transistor anymore. You can just choose the basic, very basic general purpose transistors, and they will be good enough. So we have only one type of transistor in the whole book, the normal NPN one, very, very basic one, easy to get.
Yeah. Well, let's talk about, I'll see if I can share our screen here. Talk a bit about the very first circuit you present in the book.
Yes, so this is
I will bring it up in a moment.
okay.
Give me,
Yes,
let me just share screen and fumble my way through this. Here we go. Oh, is that it? It's not it. Just a minute. Well, here we go. All right. So, do you see that?
I see it.
Okay, good. So, explain what's going on here.
Yes, so to the right, let's start with the right. So top is like a schematic or an illustration, and bottom is the actual circuit built. And the circuit is the modern take of a crystal receiver. So there's a coil in green and a capacitor, which is the box at the bottom. These together form a resonant circuit, which you tune to the frequency you want to receive. And then the blue thing is a diode, which would in the past have been a crystal of some semiconducting material, but now you can just buy a diode component. And with this, you can receive AM transmissions. And you do need a long antenna for that because this radio is not powered at all. But if you happen to live close to an AM station, you can receive that. And if you don't live close to an AM station, you can use the circuit on the left, which is a test transmitter, which this receiver can pick up. And this test transmitter uses two of the basic timer chips, the 555 timer chips. One of them will make a tone, audible tone, and the second one will make a carrier wave on somewhere in the AM radio band. And the slow timer turns the fast timer on and off. So this creates like an AM tone signal, which you can pick up on this very simple crystal.
So on the left we have a transmitter. On the right we have a receiver.
Yes, exactly.
Okay.
Exactly.
Okay.
So this is the first experiment, and already in the first chapter you can send a signal then a few inches. But anyway, it's wireless, right?
Right. And then you kind of go on in the second chapter to build a full AM radio. Is that right?
Yes, yes. So it takes the concepts of this crystal radio, but it adds transistors for amplifications. So with that, you don't need a long wire antenna, but this coil on the ferrite rod is enough. The ferrite rod, by the way, in the bottom right picture, it's the black rod. So that is enough to pick up the magnetic field of the radio wave.
All right. Okay. Should we go on to your chapter 4 and talk a bit about?
Yes, sure.
Okay. This is the Raspberry Pi Pico, which you used then from about the 4th chapter on.
Yes. So I chose this because adding a microcontroller it brings quite a lot of possibilities because you can do accurate timekeeping. And in chapter 4, I just introduced the Raspberry Pi Pico and connected to this LCD screen that you see on this image. And now in hindsight, it's quite a lot of setup work to get the microcontroller up and running, and especially if you want to explain it very carefully so that readers can replicate it. But then in the later chapters, it does pay off because the same basic setup can be used for many radio applications, both for counting or measuring frequency and for transmitting signals. And then it also comes back in remote controls.
Yeah. So is that sort of what's really new in radio, you might say, in the last 20 years or something, is kind of digital control?
There has come a lot of digital stuff in radio, but it has been coming there for a very long time. So even the old amateur equipment from, I don't know, 90s on would have some digital components, maybe a digital frequency readout, or the more fancy equipment would have even digital signal processing coming at some point. So I think as these digital circuits have become more sophisticated, this has slowly eaten into the analog workings.
Yeah. Okay, I'm going to go on. I think it's the next chapter. A couple of images here from the book.
Yes.
Let's explain them.
So this is from chapter 5, where we build a test transmitter using the Raspberry Pi Pico. So it does the job of the 2 timer chips in the first chapter. So you generate again an audio signal, square wave. You see it in the bottom of the 2 oscilloscope-like plots, and then you fill in the pulses with a high frequency oscillation. So this again is an AM modulated beep, just a tone.
Okay.
And I see a question, what bands can this transmit on? That's a good question. You can generate signals up to 60 megahertz, but as the higher you go, the less control you have of the exact frequency. So I've been using it mostly in the AM broadcast band, which is where the AM receivers easily are, and the ones built in the book are also there. So for the fast signal, the carrier frequency, I use a feature of the Pico called pulse width modulation. So the Pico has hardware for making an accurately determined frequency, and that means you don't have to program this. You don't have to do the work yourself of generating this high frequency signal with code. You can just ask the pulse width modulation hardware to make the signal for you, and that means the frequency is quite well controlled.
Yeah. Okay. Is there anything else you want to explain on this? The Raspberry Pi, it's just really the schematic for
the simplicity of it. So basically there are no components needed for making the AM signal. So you see at the bottom right, connected to pin 20 is a 100 ohm resistor and then a small loop of wire, and that's it. So you just send the signal from the Pico to this pin 20, and the wire loop will transmit it for a very short distance. And everything else you see is related to driving the LCD display, and the trimmer on the top right is for selecting the frequency. So that's like sugar, but the Pico does all the job of, or all the work of generating this AM beeping signal. So that's maybe the nice thing with microcontrollers, that you can absorb quite a lot of functions into them, and then you don't need so much hardware on the side.
Yeah. Can you talk a little bit about software-defined radio, which is
yes. It's also a thing that has been coming since maybe the past 20 years. It has slowly emerged. And it's very fascinating because it means you can do some of the radio work, the work that the circuits would do in a traditional analog radio. You can move that to software. So you would have some radio hardware, and then at some point an analog to digital converter, and then you would do the final processing in software. That gives quite a lot of flexibility because you can just change the program, and then you would have new modulation modes for your radio, for example.
Yeah.
And there's also very, very cheap hardware available for this for
Right, this USB thumb drive kind of
exactly
things, and actually they do plug into a Raspberry Pi and work pretty well.
That works, yes.
Yeah. We have a question here, Michael Newman. If you're connected to the Pi via SSH, can you omit the LCD screen and see the messages as console logs and set the frequency in your code?
I don't SSH to this because this is not a Raspberry Pi. It's a Raspberry Pi Pico, which is a microcontroller, not a full computer. But we do connect by a USB cable, and you can access output from the Pico's program. For example, if you have the Arduino environment, you can use this serial terminal, and from the program you can print to the serial terminal. So in that sense, you can get output from the Pico's program to your computer screen.
Good. We welcome questions in the chat. Please, relative to what's on the screen, or which we're going to get off of in a minute. I just want to.
I saw one question there. Maybe I can address. I didn't catch the whole thing. Someone mentioned nasty harmonics, and that's absolutely true. So if you make a square wave like this, you will have not just the frequency of the square wave, but the odd multiples of this frequency as well. And if you want to do anything more than transmit for a few inches to your receiver, then you should take care of these harmonics. And indeed, a simple filter, we do add it in chapter 6, I think. When increasing the transmission range with a transistor, it's also a good moment to do something about those harmonics. So you can make a resonant circuit with a coil and a capacitor and tune that to the fundamental frequency, and then you will see much less of these harmonics. And of course, if you start adding any power to this, you should care about the harmonics because they might disturb someone else, and this is never a good thing. And it might be illegal. So.
Okay. So actually, that's a point. I think the work you have in this book, no one is required to have a license to build the circuits in this book. Is that right?
Yes. That was the idea, to not require an amateur license, for example. The last chapter of the book talks about amateur radio, but I wanted to start from building stuff, and then maybe once you get interested, you would go for the amateur licenses. But it felt like too much to require to get the license first and then come to the book, right?
Right. Okay, good. And let me see if I can just change that. I thought I'd mention this. This is the Make Radio Component Kit, produced by Protect Trader. It's available directly through them, but also on Makershed. And so, I have, let me get out of my shared screen here. I have a box here with it, and, it's kind of not good on the camera, but, some breadboards. I've noticed a small radio in here, AM radio. But, do you want to talk a little bit about what you helped identify all the pieces and things in here?
So yes, this was a puzzle to figure out what components to ask for, because of course the more components you have, the more you can build, perhaps. But on the other hand, the price goes up and it's harder to get. And it's also nice if you can use the book without buying the kit. That was one goal, that you can shop for this yourself if you want to.
Yep.
And but anyway,
So the components are listed, in the beginning and and in the book if you want to source them yourself.
The appendix lists everything and also some advice of how to buy them, where
Right.
and what to look out for. And yes, we did. It was a big topic for the book, and it's something that doesn't matter so much if you do your experiments. I mean, me as a builder, I can just like buy for myself components and have a good stock of them. But once it becomes a book, and you have to think about the readers wanting to build the circuits and then making life simple for them. So I tried my best to reuse components between the projects. So if there's a 1 kilo ohm resistor here, then I should use the same resistor next time, and such things.
Right.
But
what I've asked this of ham radio folks before, who sometimes worry that this is a thing of the past and that the current generation isn't interested in it. But I don't know, it sort of goes back and forth on that. But why would you tell someone to be interested in experimenting with radio today?
Today, I think today and anytime really. For me, it's because it connects something very fundamental in how the world works, like the electromagnetic waves, which go anywhere. You can't see them, but with a bit of circuitry, you can make a wave here, and then someone else can pick it up somewhere very far away. And I think this is like magic. Almost. And it gives you a handle on this something that's otherwise abstract physics, but it lets you connect to this physical phenomenon and also use it and send and transmit messages to far away. And the other part, which I like personally, is the treasure hunt, because you can receive signals from far away. You don't know what you will find, but maybe you can figure out where does this come from, and just searching for this and finding. And if you do get the amateur radio license, also the challenge of communicating over long distances with people far away.
Yeah. Bill Tandy asked a good kind of question. Does a radio wave have a 3-dimensional shape?
Yes, it does. In some way. I mean, the electromagnetic field exists in 3 dimensions, and then it changes in time. What more can I say about it? It's somewhat complicated, but yes, it does.
So radio, and your interest in as a kid in tinkering with electronics, led to your being a physicist. I understand that's what you do today.
Yes.
Can you explain a little bit about what you do for work?
Clouds. I simulate clouds. And I think about the processes that make the clouds and how the clouds interact with each other. And of course, then weather and also climate.
But is that like you're building models of clouds and seeing how they form and
yes,
and what they
it's
do?
a lot of computer models. I'm in the niche of computer modeling the clouds. So we have this research model for simulating clouds, and I keep developing it in collaboration with lots of other people, and also then design experiments with the model, some particular clouds to simulate, and then run it on supercomputers usually, and try to make sense of the results.
Bill asked another question here. Is there a way to estimate the volume of the water in a particular cumulus cloud?
There should be. I like cumulus clouds. They are really my thing. So you would need to know how much water there is. You can know something about the water content per volume unit, and you can know the size of the cloud from measurements there are like laser measurements. So if the cloud passes over you, you can see how big it is. So I think you can. I should give you some numbers, but at the moment I don't have them in my head. I'm sorry.
Right. Okay. All right. Well, before we go on, I wanted to award a free copy of Make Radio and the Make Radio component kit to one of our folks who showed up today and joined us. So Jamie did a random drawing of names that are people here, and she chose a Pat Wilson. Pat, are you there? Will you kind of say hi in chat if you're there? All right, we'll wait a minute. Hopefully. Pat, I'm sorry, you're right, Pat Watson. I misread it. Pat Watson. Pat Watson. There he is. Or she. Hi, Pat. Pat, where are you from? And Jamie will Avon, New Jersey. Great. Jamie's in New Jersey. But she'll ask for your address and we'll send that out to you. And congratulations. I'm glad to give that away. I don't know if there's any of you that already have read the book and done anything in it. But if you have specific questions for Fredrik, it's a great opportunity to ask them. So do type that in the chat. Okay, Kevin. Kevin is your book editor at Make. He said, "Can you talk about some of the uses of radio outside of traditional transmitters, receivers like metal detectors and remote controls?"
Sure. Both of those are examples from the book. And the metal detector is there because it illustrates something about mixing signals and how you can take two high-frequency signals and combine them and get an audio signal as the result. So I'm not sure I would call the metal detector a radio in itself, but it felt like a good introduction to this signal mixing idea, which is very powerful and important for all more advanced radios have some mixers in them. And remote controls, yes. So the ones we use in the book are on the ultra high frequency band, so they have a quite short range, and they are used typically for wireless car locks and lamp controls, and quite fun to tinker with because you can build maybe two microcontroller devices and have them exchange simple messages, or wireless doorbells or control lights, as I said.
Mm-hmm. Okay. One of the problems we ran into early on at Maker Faire was having, when you had RC toys there, you had R2D2s and other people, you kind of have a lot of things going on different frequencies.
Oh yes, I can
And
imagine.
we would have to get people to declare what frequencies they're on and stay off the others. So it's kind of an interesting problem. Sean Morris asks, "What's your favorite antenna to use?" I guess there's all kinds,
Yes,
depending
there
on
are
what
all
you're trying to
kinds.
do here.
So, well, I can mention one, which is the very basic dipole for shortwave. I've been playing with amateur radio now again in the summer. After finishing the book, I've had a bit of spare time. And I have played with that, transmitted also. And I've been using this kind of random wire or long wire antennas before, but now I bought recently a dipole with a proper balloon transformer in the center, and it made a huge difference. I like it very much. So
Good.
it gives me
Yeah.
less noise than the random wire.
Okay, good. Anthony Good asks, "What can we do to get more makers involved in amateur radio?" It's kind of a version of the question I was asking earlier what types of projects in areas of amateur radio might be more attractive to makers.
So yes, good questions. Good questions.
I
I
would
would
welcome
hope that
anybody in the audience that has answers as well
I would
to
be
weigh in.
interested, but from my side, I think the answer is this book, because this is what I would do to get people into amateur radio or radio in general. But I think amateur radio it's really a great hobby, and it's a good path forward from uh, being interested in the project in the book. Um,
Hmm.
so yeah,
Good.
start tinkering, build stuff,
Yeah.
and
Yeah.
learn that way.
Yeah.
That's my
I
first
think
thought. Yes.
the other side was that you kind of mentioned with electromagnetic waves is just the idea of being able to receive a radio transmission and figure out where it's coming from and how far it traveled is kind of if you're curious, that's an interesting problem space.
Yes. Yes. Yes.
Yeah. Okay, a couple more questions in here. Can you explain how an antenna made out of just wires can have gain?
Oh, gain. Gain is tricky. You have to be careful. Gain compared to what? If you speak about antennas, typically gain is compared to some kind of isotropic antenna. So gain is then a form of directionality. So you would have some theoretical antenna that listens equally in all directions. And then if you have a very directional antenna like this old style TV antennas on the roof, they point in a certain direction and they are sensitive in that direction. Then gain would measure how much more sensitive it is in this direction compared to the isotropic one. I
Okay.
hope this answers somehow.
All right. AC responds that one of the answers to that previous question was that SDR radios are a good place to start for some makers as a hobby. And JD Tioferro says receiving satellite transmissions and the space station and others. I think you can um, pick those things up as well. Lawrence Scofford asks, how's your work on clouds and atmosphere given you any insights into RF propagation?
Oh,
Radio.
nice question. Uh, the space of this is very, very large. There are some overlaps. So I don't work directly on weather satellites, but I care about the weather satellite output. The data sets they make is really amazing. So, so one thing, you want your satellites to transmit on a frequency that goes through the atmosphere and not one that's reflected back and forth. So you should pick a frequency that's high enough not to be disturbed by the ionosphere. And otherwise, the clouds don't do so much with radio, but lightning, thunderstorms and lightning, you can hear on radio. So that's one point of connection.
Okay.
I used to have colleagues simulating lightning. We did have some discussions.
Yeah. Do you use radio and weather balloons in your atmospheric work?
Oh yes, not me personally, but again, the weather balloons are very important for getting good quality data, and they always have a transmitter, so they send over radio the things they measure.
Okay. Alberto's asking about crystal radios, and I'll just start by in one of the promos in the newsletter for Make I did last week. I was explaining a little bit about crystal radios, but um, you know, the idea originally was a crystal radio. You were building it with kind of things you could find around the house and be able to receive a transmission using a crystal as a diode, right?
Yes, exactly.
And it still works. You can still do that, right? But
It's
it's
fiddly. I didn't want
yeah,
it for the book because it's so random how you get this crystal to work. So
yeah,
I opted for using a common diode instead. But of course, you can
right,
probably take the same circuit and then I don't know,
right.
razor blades or something are supposed to work as
Yeah. So Alberto is kind of asking, about how doable a crystal radio workshop would be. I think I guess so. What are your advice suggestions for simple kits? And I think what you're kind of saying is it can be kind of frustrating to get it to work. It's a
Yes.
simple idea, but it's not always going to
So
work.
I would maybe, oh, I already made this choice, so I can just say that my choice was what's in chapter one, which
Right.
is to make this ferrite antenna with the coil and one of these variable capacitors, and by a Schottky diode, not a germanium would also work, but Schottky are more um, modern, otherwise quite similar in performance. So that's the first part of the advice. And the second part of the advice is to have some test transmitter. Uh, the workshop participants don't have to build it, but just have one for the workshop so that you can test your receivers with a known signal, and then you know that you can receive something, because otherwise you might rely on picking up a station or not, and you don't really know if the signal is strong enough for your simple radios to pick it up. So
By the
the
way,
test
I just
meter is
thought of
important.
another answer why makers might care about radio and why it should be important today. I personally got a ham radio license about 2.5, 3 years ago.
Nice.
Mainly for emergency communications and
Yes.
participating in emergency networks. We have a lot of fires where I live, and when the internet might go down or cell towers go down, the fallback certainly is radio communications and trying to connect the people in that manner. So, climate change and everything else, we seem to have more of those emergencies. It's
Yes.
useful to be
Yes.
prepared for them.
This is true. It's an important aspect of amateur radio, this preparedness to
Right.
communicate. I know in the
And
US
there,
it's a
just
big.
if you're not familiar, there are probably groups in your area that do it. They have regular trainings and practices, and seems like a really good thing. Mike Thielen asks, can you use a satellite communicator without buying a subscription plan? And I think when we were talking about satellites, we just meant like sort of like NASA satellites or space stations. I don't think we meant like satellite TV, um, but
Right. Um, I know
because
there
those are
are
scrambled a
amateur.
bit, aren't they?
Yes, I expect they are. But there are amateur radio satellites, and I think the International Space Station also used to have, or maybe it still has, I don't know now, a
Right.
transponder or a repeater. So you can send the signal there and it will retransmit it back to Earth. And then you can use the satellite or the space station, to relay a communication. And you don't need subscriptions for this. You only need an amateur radio license.
Good. All right. Terrific. What was this question here? Uh, where I lost it. Oh, maybe I missed it. There was there it is. Anyone into ADSB tracking? I'm not sure I know what that is.
Oh, I know what it is. I even mentioned it in the last chapter as a use for software-defined radio. So ADSB, it's an automatic identification system used on aircraft. So
Oh, okay.
every plane will transmit its position and its heading and its speed and some information like this on a particular frequency. And then it's used by air traffic control to just keep track
Okay.
of where
Yeah.
everyone is. And you can receive
Yeah.
this and plot it on a map, and it's quite fun.
Flight tracker and yeah.
Yes, yes.
Bobby says I track flights across Texas. So yeah,
Nice, nice.
that's good. Okay. Um, I guess let me just put a last call for any questions for Fredrik, particularly related to the book. But Carl asks about, will there be a recording? Yes, we will put up a recording and send you a notice about it. I'm glad you're interested in listening to it. Um, Someone's talking about Earth, Moon, Earth bounce.
Yes.
Is that bouncing signals off the moon?
Yes, you can do it. If the frequency is high enough so that it goes through the atmosphere, and then you can just point your antenna at the moon and you transmit, probably with quite a lot of power. And then you hope that the signal bounces and comes back, and you can communicate with other people if they do the same. They also point their antenna at the moon, and then you can have two-way communication with a bit of delay, of course, because it takes so long to reach the moon and come back.
Hmm. Benjamin asked, did you find all these components lying around? You probably, did you have a workshop? I found that many of these parts were hard to find in America.
Oh, um, I'm sorry to hear. I hope the appendix in the book would help.
Yeah, I don't necessarily think that's true. Um, they used to be harder, and a lot of, gosh, there's so many good electronic supply places um, out there. Okay, Carl asks, says I'm an electrical engineer. He's halfway through the book, so I know some of the stuff, but I'm also the education coordinator for our club, and I'll recommend the book to our club members. Great, great.
Oh, very nice.
Anthony recommends Mouser. Yes, Mouser, Newark. DigiKey, a lot of electronic parts. Sometimes it might be intimidating. That's why the kits can be useful. When early on when we started Make, we just a lot of the parts list for projects were stuff that makers had on hand, and they were a little bit hard to find. And we kind of realized we had a segment of readership that were like teenagers who went to mom and dad and said, "Hey, I want to build this project. Can you get me those parts?" And they really
I've
didn't
been
want to
there.
hunt over a lot of different sites to find
Yes,
those parts.
yes,
So
yes.
that's one of the places kits can come in. Micro Center, Adafruit, Jameco, all of those places are great. So we have really quite a few places. And Anthony Good says anytime someone throws out a piece of equipment, grab it and scrounge parts out of them. And even that's almost not a bad way to get some ham radio equipment that
That's true.
even though it's old, it still can be useful. Yeah, so a lot of suggestions in the chat there for different places to buy things. It 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 can be difficult. The nice thing about having the specs in the book is that you're not just buying a generic thing. You need a uh, certain specs for it, so you have to get those
Yes.
right. And yeah, we all lament a little bit in America. Remember the demise of Radio Shack. That's just
Oh, yes, I've heard of
too
this.
bad.
Big
Yeah,
loss.
yeah. Okay. Well, let's kind of wrap up. Any other thoughts you have about your book, and any thoughts that you want to share with this audience?
Thanks for the questions. It's very nice to get questions from so many of you. And I saw lots of them come by and I can't follow, but I'm really happy. I hope I can get this later on as well. And I saw many radio amateurs in the chat in the beginning, so that's also
Yeah,
very nice that so many of you are also in
yeah.
here.
I'll tell you one. I didn't really look at the Q&A section. I was looking in the chat all the time, but there's a nice one. He said his late friend was an amateur radio astronomer. And could you talk a bit about radio astronomy?
Oh, okay, nice, nice. I don't know a lot, but oh yes, I do know. So stars emit also radio waves, and if you make a big antenna and you point it to the sky, you will pick up radio waves, both from the stars and from just the universe in general. And I think this is very fascinating. And nowadays, you can use these software-defined radios to receive these signals. So you don't need that much equipment. You do need the big antenna, maybe some amplifiers and stuff, but the receiving itself you can do with these software-defined radios that you can buy for not huge sums of money. So I think this is a fascinating place where radio and the tinkering crosses science and or other kinds of science.
Yeah, and I think that's what comes across in your book is kind of radio as a set of tinkering projects, things to both, learning electronics and learning about radio. And you bring those together very clearly. So Chris Stewart, I put a link in there from his first crystal radio from the Boy Scout handbook when he was a kid. That's kind of nice to see. I think everybody wants to thank you, Fredrik, for being on here, for writing the book. Thanks also to Charles Platt for being in the audience and also his work in inspiring the book and helping you get it done. We don't have any videos or courses that accompany the book, answer Don's question, but that's a possibility down the road somewhere. We'd love to hear from you if you build some of those circuits. Send us some notes and we'll put them up somewhere. So thank you all for joining us today. Thank you, Fredrik. And
thank you.
I hope it inspires a lot of people to get involved in radio.